which is question number 81. Let's read it. A solid compound XY has NaCl type structure. If the edge length of unit cell is 800 picometer, then the radius of the anion will be. Student, here, first of all, we are given with NaCl type structure. Here we are given with edge length, which is 800 picometer. We have to calculate the radius of anion. So for NaCl unit cell, one thing we have to keep in mind, that the radius of cation plus radius of anion is equals to A by 2. Also the radius ratio, that is radius of cation upon radius of anion, is equals to 0.414, since here in NaCl type structure the cations occupy octahedral voids. Now student, A by 2 is equals to R plus R minus. Let's put the value of R plus R minus here. Here we are given R plus upon R minus is equals to 0.414. So R plus is equals to 0.414 R minus. If I add R minus on both sides, R plus R minus is equals to 0.414 R minus plus R minus. Taking R minus common, R minus is equals to 0.414 plus 1, which is equals to 1.414 R minus. Now let's put the value of R plus R minus here, which is equals to 1.414 R minus. So let's calculate the value of R minus, which is equals to A upon 2 into 1.414. The value of A we are given 800 picometer. 2 into 1.414, which is equals to 282.88 picometer. That means the correct answer for this question is option number 1. Moving to the next question, which is question number 82. Let's read it. In a mixed oxide of metal A and B, oxide ions are arranged in CCP lattice, and A2 plus cation occupy 1/4 of the tetrahedral void and B plus cation occupy all the octahedral voids. The formula of the oxide is, student, first of all we need to know that the number of atoms forming the CCP lattice, if it's n, then the number of octahedral voids will also be n, and the number of tetrahedral voids will be twice of n, that is 2n. Here the number of oxide ions O2 minus is equals to n. The number of A2 plus cations, that is A2 plus cations, occupy 1/4 of the tetrahedral voids. So 1/4 of tetrahedral voids, which is 2n. So 1 by 2n, and B plus cation occupy all the octahedral voids, which is equals to n. So formula of the compound is equals to A n by 2 B n O n, which is equals to A B2 O2. That means the correct answer for this question is option number 1. Moving to the next question, which is question number 83. Select the option in which the given crystal system correctly matches with their axial parameters. Student, first of all, we are given with triclinic system, and this is an incorrect match. As for triclinic, I am writing here. For triclinic, all the edge lengths, that is A not equals to B not equals to C, and the axial angles are again not equal to each other. Alpha not equals to beta not equals to gamma, which is not equals to 90 degree. Moving to next, trigonal, A equals to B equals to C and alpha equals beta equals gamma not equals to 90 degree. Student, this is a correct match. Moving to next, this is also given incorrect. Here I am directly writing the correct for monoclinic, the correct axial parameters for monoclinic lattice. For monoclinic, A not equals to B not equals to C. That means all the edge lengths are not equal. Also alpha equals gamma equals 90 degree, which is not equals to beta. Moving to last, tetragonal. Student, this is also an incorrect match. Here I am writing the correct axial parameters for tetragonal lattice. For tetragonal, A equals to B, not equals to Z, not equals to C, alpha equals to beta equals to gamma, which is equals to 90 degree. That means the correct answer for this question is option number 2. Moving to the next question, students, which is question number 84. Select the correct statements regarding Schottky defect. It is stoichiometric defect. Student, this is the correct statement. Due to this defect, density of crystal decreases. Student, this is also a correct statement. As in case of Schottky defect, the number of cations and anions are missing in a proportionate ratio. Therefore, the density of the crystal decreases. Also, AGBR shows this defect. That means number 3 is also a correct statement. So, all the given statements are correct regarding Schottky defect. So, the correct answer is option number 4. Moving to next statement, which is question number 85. Let's read it. Select the aqueous solution which is not isotonic with 0.2 molar NaCl solution. Student, first of all, we need to understand the meaning of isotonic. The solutions which have same osmotic pressures are isotonic in nature. So, let's start with 0.2 molar NaCl. So, here I'm writing for NaCl. The value of pi is equals to I CRT. I for NaCl is 2. Concentration is 0.2 RT, which is equals to 0.4 RT. Moving to next, urea. Pi is equals to, here for urea, I is equals to 1. Concentration is equals to 0.4 RT, which is equals to 0.4 RT. Moving to next, KCl solution. Here pi is equals to ICRT again. I for KCl is 2. Concentration is 0.2 RT, which is equals to 0.4 RT. Moving to the next solution, CaCl2. Pi is equals to, I for CaCl2 is 3 multiplied by 0.1 RT, which is equals to 0.3 RT. Moving to the last solution, AlCl3. Here pi is equals to ICRT. I for AlCl3 is 4 multiplied by 0.1 RT, which is equals to 0.4 RT. That means all the given solutions are isotonic with 0.2 molar NaCl except the solution which is given in option number 3, that is 0.1 molar CaCl2 solution. So the correct answer is option number 3. Moving to the next question.